Welcome to this short presentation on how the Indian mathematician Srinivas Ramanujan's breakthrough enabled the calculation of pi to many millions of digits. Many of us have encountered pi in school. It is the ratio of the circumference of a circle to its diameter d. The value of pi is the same for all circles. From ancient times, every civilization has estimated the value of pi because it is required for making circular objects as well as in construction and in astronomy. In ancient times, geometric methods were used to calculate pi. A regular hexagon was inscribed in a circle. Then the perimeter of the hexagon ABCDEF was calculated using Pythagoras' theorem. The more the number of sides to the polygon, the closer it is to a circle and better the value of pi. By such methods, the value of pi was calculated to be square root of 10 or a fraction 22 by 7 or similar. It was also known that these were approximations. Generally, these estimates were correct to 2 to 4 decimal places only. By evaluating polygons having many thousands of sides, in the 5th century, a Chinese mathematician calculated pi correct to 7 decimal places. 1,000 years later, a Persian mathematician reached 16 decimal places, but this was very, very laborious work. Now let's look at the modern method. Pi is evaluated with the use of infinite series. This was first done some 600 years ago in 1400 CE by Madhava from Kerala, India. He developed infinite series for various trigonometric functions. He used one of them to estimate pi correct to 11 decimal places. So what makes the value of pi so interesting? Pi has an important place in modern physics, maths, biology, electronics, etc. Also, mathematicians found that pi is an irrational number. That is, in decimal notation, it is a string of numbers that never repeats and has no end. This idea fascinated mathematicians, so they developed many infinite series for pi in recent centuries. But they all required tremendous effort to calculate more than a few hundred digits of pi. A breakthrough occurred in 1914 when Srinivas Ramanujan, the Indian mathematician, published 17 formulae in his paper titled Modular Equations and Approximations to Pi. Mathematicians found them to be remarkable for their elegance, mathematical depth, and rapid convergence. Of these formulae, this one became famous. It contains some large numbers, some factorial terms, and some exponential terms. It is an infinite series where each term has to be evaluated for values of n from 0 to as high a number as possible. This complex formula is today derived by the use of advanced mathematics concepts such as elliptic integrals, theta functions, Ramanujan G invariant, hypergeometric series, Dirichlet L series, etc. All this is just an indication of Ramanujan's genius. The beauty of this formula is that it enables a rapid calculation of pi, faster than any previous formula. The very first term gives pi accurate to 7 decimal places. Each additional term improves the accuracy to more decimal places. These features so enamored enthusiasts that people have calculated pi up to 2,000 decimals by hand. For mathematicians, it was a dream come true. With the advent of computers, people started evaluating Ramanujan's formula to calculate pi to more digits than ever before. In 1985, over 17 million digits of pi were calculated, a level unthinkable before Ramanujan's magnificent contribution. Just imagine how thrilling this would be for Madhava and previous mathematicians. An improvement over Ramanujan's formula was discovered 74 years later. Based on Ramanujan's work, the Chudnovsky brothers found another formula in 1988 that was faster at calculating pi. It belongs to the same class of functions as Ramanujan's formula and has the same form. In the very next year, 1989, it was used to calculate pi to 1 billion decimal places. The development of ever more powerful computers and of mega storage devices has enabled the calculation of pi to greater lengths. It's an opportunity for the computer industry to demonstrate its prowess at supercomputing. The number of digits calculated for pi has increased by leaps and bounds. 2.7 trillion digits in 2009, 10 billion digits in 2011, 10 times that to 100 trillion digits in 2022, double that in 2 years to 202 trillion digits in 2024, and now a mind-blowing level of 300 trillion digits in April 2025, certified by Guinness as a world record. So here are some fun facts. It took 225 days non-stop to complete the calculation. The validity and accuracy of the digits were checked by special methods. The cost was about $1 million. To understand the magnitude of a number like 300 trillion, here is one example. If 25,000 digits are printed on one A4 size page, then 12 million books, each of 1,000 pages, will be required for all the digits. And here are some highlights about the digits. The last digit at place 300 trillion is 5. All 10 digits 0 to 9 are found in sequence after some 17 billion digits. And after some 22 billion digits, a string of 10 consecutive sevens occurs. These advances have been possible due to the foundation laid by Srinivas Ramanujan with his path-breaking formulae for calculating pi published in 1914. Here are the first few hundred digits of pi. Here are the important formulae mentioned in this presentation. The first infinite series from Madhava is given. Then comes Ramanujan's key formula, and lastly the Chudnovsky formula. It can be seen that the Chudnovsky formula has a form very similar to that of Ramanujan's formula. The information in this presentation is drawn from these references: Wikipedia articles on pi and the Madhava series, a recent proof of Ramanujan's key formula, a Wikipedia article on the Chudnovsky algorithm, a news article about the computation of 300 trillion digits, and an overview by a mathematician of Ramanujan and pi. Thank you for watching. I hope you have enjoyed this brief description of mankind's long journey in the calculation of pi.